Pluto is a far-off and stealthy, more humble planet that was once a piece of our nearby planetary framework. However, late, upsetting articulations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with a stunning disclosure. They propose that this cold world is on a potential impact course with Neptune. But how could this work out, and what may be the results of such a monstrous event? Are we seeing an interesting grandiose quirk, or is there something else to this coming divine mishap? Join us as we investigate the expected consequences of a Pluto-Neptune impact. Pluto, a former planet that was downgraded to a dwarf planet due to its unusual orbit, remains a subject of interest and study in the vast astronomical community. According to recent conjectures by leading researchers, Pluto's orbit is perilously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a possible dangerous collision between these two planets, which could pose a significant threat to Earth. But how is such an event even conceivable? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It requires an amazing 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even finished one full revolution. However, the interest doesn't stop there. Pluto's orbit is marked by its highly elliptical shape, wandering widely from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unique is its inclination at 17 degrees to the ecliptic plane. The way Pluto follows its path is much more tilted compared to other planets. This tendency and unpredictability add layers of complexity to its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its intersection with Neptune's orbit. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect based on their positions in the solar system. This leads to the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to figure out its unusual path. Unlike other planets, whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stood out with its steep inclination and elongated shape. The mystery deepened with the realization that Pluto's orbit does, in fact, cross Neptune's. The stability of Pluto's orbit amidst these complexities is proof of the intricacies of space mechanics. The three-body problem in space involves determining how three objects like Pluto, Neptune, and the Sun move and interact with one another through gravity. It's like trying to predict where they will go based on where they start and how they pull on each other. For Pluto's case, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. The terms ASU libration, degree libration, and VZK swaying are part of this riddle. According to astrophysicists, what keeps all planets in their orbits is ASU libration. As for Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from meeting. Degree libration, on the other hand, refers to the vertical movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, offering an extra layer of protection from possible impacts. Another significant aspect of this scenario is the VZK swaying, named after three researchers, Zell and Kai, who studied how objects move in space. It involves how three space objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This gravitational force influences how they move. For Pluto, the VZK swaying helps us understand why its orbit around the Sun is so strange. Despite Pluto's orbit seeming erratic, this swaying ensures it moves smoothly over long periods. The VZK swaying shows that, although things in space appear chaotic and unpredictable, certain patterns and forces keep everything in place. All these factors help keep Pluto's orbit stable, ensuring it doesn't collide with Neptune or drift off course. This three-body problem is essential to understanding how these orbits evolve due to the way space objects interact with one another. Studying this helps us learn more about Pluto, our solar system, and even distant planets and stars. Numerical simulations in the late 1980s revealed that, despite these steady properties, Pluto's orbit is actually turbulent, with small deviations in initial conditions leading to significant changes over thousands of years. However, these remarkable properties of Pluto's orbit have been shown to maintain stability over extraordinarily long timescales, keeping the disturbance under control. Later computational models have helped us understand how the giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune completes 3. This relationship helps keep Pluto's orbit stable. However, Neptune isn't the only player. Jupiter's gravity also plays a crucial role in stabilizing Pluto's orbit, as does Saturn's. These simulations show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a steady path for many years. Indeed, even millions of years. So, it's as if Neptune, Jupiter, and Saturn are all working together to ensure Pluto continues to move safely in space, without running into trouble. These characteristics are essential for maintaining order and stability in space. Without these factors, our solar system would be a much more chaotic place, and bodies like Pluto could collide with others or be ejected from their stable orbits, setting off a chain response with other divine bodies, especially with conversations about Pluto possibly colliding with Neptune later on. Grasping its circle is significant. This gives a clearer image of the unique idea of the planetary group. The instance of Pluto shows how even the most apparently unsound circles can reach a condition of harmony through the complex association of gravitational powers and orbital mechanics. It also shows the significance of ceaseless perception and investigation of these peculiarities to better grasp our spot in the universe. Investigating the profundities of space frequently drives us to confront the peculiar nature of divine bodies, and Pluto's circle is an ideal illustration of this bizarreness. The concept of orbital disarray, which refers to the sensitive reliance of a divine body's circle on its introductory circumstances, is clearly represented for Pluto. This means that even slight changes in the dwarf planet's position or speed can radically change its long-term circle. Utilizing computational models has been enormously helpful for analysts in sorting out how Pluto moves in space. These simulations use complex arithmetic to demonstrate how Pluto and other space objects like Neptune pull on one another. By tweaking little subtleties in the simulations, space experts can perceive how even small changes can have a colossal effect on where Pluto ends up. In the late 1980s, these simulations revealed something fascinating about Pluto's circle. Even though it has mechanisms like AIML and scope vibration to keep it stable, its circle can still be capricious and turbulent. If you start with only a small difference in where Pluto is or how fast it's moving, its circle could end up looking totally changed after a number of years. However, even with this mayhem, Pluto's circle remains stable over extraordinarily significant lengths of time, like billions of years. This means that Pluto's excursion around the Sun has a kind of order to it, despite the fact that it appears tempestuous at first. Predicting divine events, especially when they involve sporadic circles like Pluto's, is an enormous challenge. The inherent unpredictability of these systems truly means that long-term predictions are often filled with uncertainties. While numerical models provide significant tools to comprehend and predict the future ways of heavenly bodies, they also highlight the limitations of our predictive capabilities. These models depend heavily on the accuracy of introductory circumstances, and any little mistake or distortion can lead to vastly different results, making exact predictions a complicated task. Additionally, the turbulent nature of planetary circles like Pluto's reminds us of the ever-changing and dynamic nature of the universe. While we've made tremendous strides in understanding space, Pluto's case serves as a humbling sign of how much our insight into the universe still remains limited. Understanding the gravitational impacts of the giant planets on Pluto's circle provides critical insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can fundamentally influence the stability and direction of other bodies within the system. So, why are prominent astrophysicists recently raising concerns about a possible crash between Pluto and Neptune, despite all these complex powers trying to prevent such an event from happening? Neil deGrasse Tyson, a prominent astrophysicist and a significant figure in advancing cosmology, offers a captivating perspective on the mysteries of our planetary system, especially the intriguing case of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, provides a thoughtful analysis on the evolving nature of divine mechanics and the public's interest in the neglected domains of space. Tyson's position on Pluto's renaming is based on the ever-growing knowledge of our solar system. He sees the renaming not as a downgrade, but as a significant change in line with our developing understanding of the many bodies circling our Sun. Tyson's approach to heavenly mechanics is one of constant learning and adaptation. He sees the intricacies of circles like Pluto's as an indication of how much there is still to discover in space. The interest in these questions keeps the investigation of space so intriguing. However, despite Tyson's confidence, his thoughts on Pluto's possible crash with Neptune paint a much more uncertain future. He stresses that the circles of Pluto and Neptune will continue to evolve, driven by forces that are sometimes unpredictable. Interestingly, Tyson also mentions that these uncertainties could potentially lead to Pluto drawing closer to Neptune's circle over the next few million years. Nevertheless, he remains hopeful yet somewhat cautious about the probability of such a crash. Tyson's analysis suggests that while the chances of such an event happening are low in the short term, the unpredictable nature of planetary circles means we cannot completely rule out the possibility of such a collision in the distant future. In addition to Tyson, Michio Kaku, a prestigious theoretical physicist, also comments on the implications of Pluto's potential collision with Neptune. Kaku's research combines cutting-edge physics with a deep understanding of astronomical evolution. He believes that such a collision, if it were to happen, could have significant consequences, not only for Pluto and Neptune but for our understanding of the universe as a whole. According to Kaku, a Pluto-Neptune impact could set off a cascade of other events, potentially even changing the nature of the solar system as we know it. However, Kaku also acknowledges that the likelihood of such a dramatic event occurring soon is highly improbable. He points out that while the circles of Pluto and Neptune are in close proximity, the vastness of space and the complexities of their orbital elements make a collision unlikely in the short term. Nonetheless, the possibility remains an intriguing subject for further study and speculation within the academic community. In conclusion, the possibility of Pluto slamming into Neptune remains a topic of active discussion among astrophysicists. While the mechanisms of their circles prevent an impact from occurring in the short term, the complexities of divine mechanics mean that we cannot rule out the possibility of such an event happening in the distant future. The ever-changing nature of planetary circles reminds us of the dynamic and unpredictable nature of our universe. Even if such an event does not happen, it serves as a fascinating illustration of how little we truly know about the future of the solar system.